Hello everyone and welcome to this video. Today we will analyze the behavior of piston connecting rod using a static simulation. In this study, we will perform a static simulation of connecting rod and piston to analyze their behavior under different mechanical constraints. The goal is to verify the ability of these components to withstand the applied forces without exceeding their strength limits, ensuring their proper functioning and safety under real-world conditions. We start by creating a new study of the static type. First, we apply the material. So, right-click, select Apply Material, choose 1020 Steel, and then Validate. OK. Next, select the piston component to define a contact interaction. As you can see here, let's select all these components. Select, right-click to Connections, and be sure to put these components in contact and validate. Then, we replace the excluded connectors with virtual connectors to optimize accuracy and reduce processing time. As you can see here, select all these components and exclude, validate. Then, we will use a pin connector. So, right-click on connection, then select the corresponding application faces. As you can see here, let's select these faces. Ensure that the type is disrupted and the material is still. Then enter the tensor constraint to 500 square millimeter. Now, let's create the bolts. First, right-click on connection. As you can see here, in the first tab, let's select the bolt edge, select, and the next second tab, select the net edge. As you can see here, make sure the type is set to disrupted and the material is still. Next, let's define the thread pitch as 1.2, set the torque to 2.5 and apply a safety coefficient of 0.2 and validate. For the second bolt, follow the same steps as the previous one. Same thing, in the tab 1, select the edge, first edge, and the second tab, the net edge, as you can see here, and make sure to set disrupted and material is still, the thread pitch as 1.2 and torque 2.5, and of course the coefficient to 0.2 and validate. Now we will apply the boundary conditions. So right click, select Fix Geometry and choose the areas to fix. As you can see here, select all these faces, select and validate. Next, we will apply the force on the upper faces. So right click, Force, select Faces and set the value to 3500 Newton and validate. For the final step, we will apply the mesh. So right-click, create mesh, and be sure to set the standard mesh as you can see here, then execute the simulation. We are going to wait a little bit for the execution as you can see here. SolidWorks is currently performing the calculation. That's why it takes a bit more time for the calculation. And here's the result. As you can see here, the piston is meshed. And here we go, the result after deformation. As you can see here, the simulation confirms that the piston is operating safely. And thank you for watching this video and see you in the next study.